is, okay, it says, all right, so just start at problem 1.
Yeah, if we could just work through the whole. I mean, if we don't get the whole thing done, that's fine. But if we could just work through one through whatever
Sure,
we get done.
sure.
Cool, thank you.
All right, so we got problem 1. A bacteria culture started with 300 bacteria. After 4 hours, the population has grown to 500 bacteria. If the bacteria grows exponentially, write an explicit formula for the number of bacteria. Okay, so there is a formula here. It's PA to the power of T. There's also PE to the RT. Do you know which one your instructor is looking for here, or maybe what you were studying in class? You might have studied both. They're both correct also.
I was about to say, I think we do both of them. I believe there's not a specific
Okay, so I'm
specific.
gonna do this one. I think it's a little bit more straightforward.
Okay.
So for part A, and this is it's going to be the bacteria. So we'll just call it P as a function of T, and the initial amount is 300, A to the power of T. So now we need to determine the value of A. So to do that, we have to use this other value here. So we know that after 4 hours, okay, so that's when T equals 4, that there's 500 bacteria. So we can go 500 bacteria equals 300 bacteria, A to the power of 4. Is it clear why those are the two values that I submitted or substituted there?
Um.
T is 4 and P of T is 500.
Yeah.
Okay, so now we need to solve for A to the 4th. So we're going to divide both sides by 300. So this equals A to the 4th. And then we're going to take the 4th root of both sides. So it looks like this. It's the 4th root of 500 over 300 equals A. It doesn't say anything in here about rounding, but we'll just assume they want you to round to quite a few decimal places. 5 over 3 to the 1/4 power. All right, so I get that A is approximately 1.1362. So we take that value and we put it back into right there. So P of T equals 300 times 1.1362 to the power of T.
And
For
then
part B, we're going to use that equation. So for part B, it says, well, what happens in 1 day? Well, 1 day is 24 hours. So they're telling you that T equals 24. So you're putting 24 in for T. 300 times 1.1362 to the power of 24. You definitely need your calculator for that one.
300 times. Should I do the 1,000 um one or yeah, the 1100 362 to the 24th power?
Just to be clear, this is 1 point, 1 decimal
Oh, one
point.
point. Okay, sorry, I'm so
Yeah,
sorry.
I just want to make sure it was clear for you. If you're using a scientific calculator, you can just throw this in all at one time. If you're not, yes, you have to do this part to the power of 24 first and then multiply by 300. It ends up being about 6,427 bacteria. Let me know when you're ready for me to move on to problem 2.
Okay,
We
System.
can certainly go over any part of this again if you would like.
I'm just trying. I'm doing it on my calculator. It's just the calculator, but I got the answer finally. I had to do it the way where it was separate. I don't
Yeah.
have a calculator screen.
Okay. And just a reminder, I'm going to send you a PDF and a screen recording of this afterwards.
Oh
Hopefully,
yeah,
you got that last time.
that was actually super helpful. Like I was like re going back rewinding the things a lot.
That's great. That's great. I actually spoke to a parent this week and I tried to explain how this is a feature of the lesson, and they were super confused. But I'm
Yeah,
glad
and
I'm glad you got it.
I told my dad too. I was like, yeah, because he asked, he was like, how did your tutoring session go? And I was like, yeah, well, this guy he sends you the lessons after when you're done, and he was like, whoa, that's so cool. He was like, he was mind blown, and I was like, yeah, it's like you can literally, even if you forget something that they said, you can go back and teach
Great.
it to yourself.
And it's nice that it's just for you. It's not a teacher doing a bunch of
Yeah,
problems. It's problems you need help with.
yeah, exactly that too.
All right. So let's start with question 2 here. It says, suppose that you have a bowl of 500 M&M candies, and each day you eat a quarter of the candies that you have. I don't like this number to start out with, but I want to I'm going to choose a different number. Choose 800,
Okay.
and we're going to do with 500. But I just want to make sure you see here. So if you eat a quarter of them, what's a quarter of 800?
Um, let me eight
Two,
hundred.
200, 200. Okay.
Oh, okay, sorry.
And then how many are left? Well, there's 600 left. So what's a quarter of 600? Well, that's 150. And then you get down to 450 here that are left. A quarter of this is 112 and 50, or 112.5. So the reason I'm showing you this is the difference between these two is 50, and the difference between these two right here is 37.5. If it was linear, a linear means you would have a common difference each time. And you can see very clearly that it's not a common difference.
Yeah.
It's 50 and then 3750, and then it would be another number there. So the fact that it's a quarter each time, that means that it is exponential. So
Oh,
okay, so now let's do it for your problem here again. Um, so because I think the first thing is to ask for is the number of candies changing linearly or exponentially? You would say it's exponential because the decrease is not the same each time. So if that's okay, I can move on to writing the equation of the model. Is that okay?
yeah, yeah. Thank you.
Okay. So we're gonna use the model again here. I'm gonna use PAT, PAT, PAT again. Um, P is always the initial amount that you have. So in this case, the initial amount is 500 because that's what was given in the problem. So the number of M&Ms left is 500 a to the power of t. Now, if you followed that what we were doing on the left there, uh, what happens the first time is you lose a quarter of these. So a quarter of these is 125. That means that if you subtract 125 from this number, which is 375, you get that amount remaining. Is that okay? Is that
Yeah,
clear?
I get that.
Okay. So here's what that means. It means that when time equals 1, and whatever that is, like it just says every time you go to the bowl, which oh, it's each day. So in one day, you have 375 left. And as long as that's okay, Um, we'll keep going here. So that means that P of 1 equals 375. So we're going to put 375 in here and a value of 1 in for T, because T equals 1. So a to the 1 is just a, so 375 equals 500 times a. We're going to divide both sides by 500. And believe it or not, a equals 3/4. And you might have thought to yourself, well, maybe I should have known that because of the 1/4 each time. So this value a, it's either 1 plus the growth or it's 1 minus the decay. Sorry, I interrupted you. What were you saying?
Oh no, I was just about to say that. Isn't it like one plus the growth and then one minus the decrease?
Exactly. So it's 1 minus 1/4, which is 3/4, but through the numbers we could get that as well. So the answer is P of t equals 500, 3/4 to the power of t.
Okay.
All right, so let's move on to problem 3. Problem 3 here. Portland's population, something. Okay. Right. Portland's population in 2007 was about 568,000 and had been growing by about 1.1% each year. All right, so 2007 is considered the base year, and that's essentially when time is equal to 0. And the initial amount, P0 or P, is 568,000. Now, you have a choice here. You can either write this, which I think is better, or you have to know that 568 is in thousands. So I'm going to suggest we go this way. So we're going to do use the same formula again. P of t equals P a to the t. A is 1 plus the growth rate. And you can see the growth rate is here, 1.1%, but it's not, you never work directly with percentages. You have to convert this percentage to a decimal. So you're going to move that decimal place over to the left 2 places. So your growth is actually 0.011. So your A is actually 1.011. So part A of the problem is just putting it all together. P of t equals the initial amount, 568,000, A, 1.011 to the power of t.
Okay.
So now part B is asking you to figure out what happens in the year 2016. They want to know 2016. We know that t equals 0 corresponds to the year 2007. So to get our t value, we're going to take 2016 and subtract 2007. So that ends up being 9. So we're evaluating it like what happens at t equals 9. So P of 9 means to put 9 in for t. So with your calculator, again, you'll have to do the base to the exponent and then multiply by 568,000. So I get 626,771 people.
Okay. I got that too.
Great. Where did this go? There it is. Okay. 5, 4. Okay. Pam is a disc jockey. Every week she buys three new albums to keep her collection current. She currently owns 450 albums. All right, so we're gonna make a table for this one because it's this is week and this is number of albums, and it'll help us to determine first, which it doesn't ask for, but you need to determine whether it's linear or exponential. And the best way to do it is to like do this, whatever it says, like she gets three new albums. So in week one, she gets three new albums, so she's up to 453. Week two, she's up to 456. Week three, up to 459. What is the increase here each time?
By
It's
three.
by
Yeah,
three. And when we have the same, when we have a common increase or decrease,
linear.
it's linear. So this one is definitely linear. So your instructor is saying write an explicit formula for the number of albums. Well, if you don't know whether it's exponential or linear, you'll write the wrong thing. So
Yeah, because they're different formulas, right?
say that one more time.
Are they different formulas, the linear and exponential?
Yeah, exactly. Like this is the equation of a line. M is your slope, and B is your intercept. We actually have the intercept here. It's the starting value. It's like whatever you started with. So you start with 450 albums. Sorry, maybe I'm pointing to that, but it's actually this data point right there. M is whatever it goes up or down by. What does it go up or down by?
By three.
By 3. So we know that M equals 3. So we're going to substitute that in. Y equals 3x plus 450. They probably want, it says formula, so you don't have to make a function here. You could say f of x equals 3x plus 450. And this is what it's looking for. Now we can check it. We can check it by, let's set x equal to 3. So like in the third week. So in the third week, f of 3, you're putting 3 in for x. So that's 9 plus 450, 459 albums. And what you'll see is that that is exactly what we got in the table up here.
Oh, okay. So then that's how we check it is we just plug
It's a good way to do it, just to make sure that your formula actually works.
words. Okay.
You know, if it doesn't work, um, so for exponential ones, you might get slightly different. Like it might be off by a little bit um, because you're rounding in some cases, but for linear ones, it should work out really well.
Okay.
So that is it. The explicit formula for Pam, that's done for that. Um, I really appreciate you not scheduling so late this time. I think I told you I removed some of those later lesson times.
Yeah, I'm sorry. Yeah, I think I even saw that there was like a 10 or something, but I was
Yeah,
like, I'm not gonna do that.
yeah. My social calendar appreciates that. Just kidding.
Yeah, I'm sorry. I'm very sorry.
No, I'm not doing it. I mean, I'm rarely going out, so it doesn't really matter. But
Yeah, I
maybe
wanted to
you're
schedule earlier too, but I had work, so I was like, I'll just do it when I get out.
great. I'm glad to hear you're working. A lot of people aren't right now, so it's good to hear that. Are you getting plenty of hours at your job? And
No, that's why I do want to find another job. Because I am also trying to like save up and move out. Like COVID kind of messed that up too.
yeah, do you mind just sharing, like what kind of work you're looking for, or what what kind of things you're?
I mean, honestly, I'm not very picky. I'm very good with customer service. I'm very like I'm really into like people type jobs. Like honestly anything. Like I've done from serving. Right now serving isn't really a thing because of, you know,
Yeah.
restaurants aren't like really popular, but like I mean like retail, like working at a gym, even working at, you know, anywhere honestly.
How are your computer skills? Are you comfortable
Um
in front of a computer?
I mean, they're not like super good, but they're not like super bad. Like I pick up pretty easily. I took a business like accounting, I think, class in like high school, and it actually helped with my computer skills a little bit.
Okay. All right. Well, if you don't mind, maybe I'll just contact you outside the lesson. I have some things I need some help with, and see if you're interested.
Oh,
Um,
okay. Yeah, cool. Yeah, totally. You can totally contact me about that and I'll see. Yeah.
yeah,
What
we'll see if it's a fit. I tried hiring someone earlier this year, and it their skill set didn't really match with what I wanted. But it's hard to find good people to do work nowadays. So
Yeah, I understand that. Yeah.
yeah. So okay. Let's jump to this problem here. Make sure we get through all this. So the number of streetlights in a town is growing linearly. Linearly. Okay. Um,
So that's the last I mean the last yeah, formula that we used, right?
exactly. So you can write y equals mx plus b. There's actually three equations of a line, but this one's pretty straightforward. When it says n equals 0, that's the b value, but that's not b. This one is this 130. That's your b value. That's what it started at. Okay. So
Okay.
we'll say y equals mx plus 130. So now we have to find the slope. We need to figure out what m is. So in the previous problem, we were able to use a table to figure it out. Here, though, they essentially give you another data point. Like I didn't write it up, but they're telling you that at 0 it's 130, and here when 4 it's 146. So we can find slope using the slope formula, which is y2 minus y1 over x2 minus x1. Your y2 is 146 minus 130 over 4 minus 0. So that's 16 over 4, which equals 4. So that is your slope. Your slope is 4. So it's y equals 4x plus 130. Is everything I've said up until now clear?
Yeah. So how many months will it take to reach? Yeah, everything up until now is clear. Yeah, I'm just confused on how much months will it take to get the 200 likes.
Okay, we haven't done that yet. We haven't done that yet. So we have to build the equation and then solve for it. So it's asking for it, saying, well, when does y equal 200? Like, and then what is x? Like, that's what we're trying to figure out, because x is the
Oh,
number
okay.
of months. So in this case, we're going to put 200 in for y, 4x plus 130, and we're going to solve for x. So to do that, we're going to subtract 130. So we have 70 equals 4x. Divide both sides by 4. So x equals 16 point, no, 17.5. So that means in 17.5 months, there will be 200 lights.
Oh, okay. I see how you solve for the 200 now.
So you have to build the equation, which we did, and then you have to solve it by um,
The
you know
200 is equal.
putting 200 in for y and solving for x.
Okay.
All right. We need to make a slight change to question 2 because I didn't use the right variable, and I don't want you to miss out on points for that.
Oh yeah, yeah.
So question 2, it said up here, which I didn't, it said write an equation after n days. Well, I didn't use n, I used t.
P. Okay,
So the only change here is that this should really be p of n
that's
equals,
fine.
yeah.
I
Well, some instructors are very picky and selective about stuff like that.
Yeah, I'll like put N, but I'm pretty sure she's used T quite a bit, so that's why I was a little surprised that.
You can actually, I mean, it's just a variable. You can use anything you want for it. Um, so, okay, so that takes care of this. Is there something else you'd like to work on?
um Actually, yeah. Wait, is that the whole assignment that I sent you?
That's it. It's
Okay,
5 questions, yeah.
yeah, perfect. Okay, cool. We have okay.
We have some time here, for 20 minutes at least. I'll just remind you, if you could send it to learning at Math by Matthew, that would be the best way to get whatever you want done to me.
Okay, let me it's from I'm really not sure how to send this because it's not a document.
If you
But
send a picture, a screenshot,
oh yeah.
whatever you got, I'll work with. If you knew, well, you might find out some of the stuff I get people send me. It's a scavenger hunt.
I
To,
can actually copy paste it and make a whole document. So
okay.
let me just do that. It's I mean I can read you the problem. It's I believe um it's a simple interest, yeah, problem.
Okay.
My computer resets, so like everything is kind of everywhere right now. Can't find Microsoft Word.
I'll just share briefly that I don't know that I've been out to eat in like 6 months because
Oh my gosh,
it's
yeah,
just awkward. I mean, it's so awkward, and
it
I
is
mean,
very awkward.
I cook at home, and I mean, I've done some takeout, but mostly been for other people when either I was visiting family or picking up for a friend.
Yeah, I work at a Chinese restaurant. So we have an option for takeout, and when people come in to eat, I'm just like, why would you do that? Like, we literally have takeout, and you're
Yeah,
wasting
and
your
that's it.
life. Let me just. And then you said to send it to.
It's right up here at the top of my screen. Learning at mathbymatthew.com. That's it's the same email that you received from me last week or 2 weeks ago, whenever that was. Um,
At mathbymatthew.com. Okay. Matthew with two T's, right?
Two T's, yes.
T's. Okay. I believe subject. I'm gonna just put sorry, that's the subject. Okay, I believe I sent it. Let me just see if you've got it.
Okay.
Otherwise, is it sending?
I received something. Okay. Homework help. I hope you have more than this. This will go pretty quick.
Okay, yeah, it is. It is just one problem. I'll send the
Okay.
document again, but I'll just be copying and pasting onto that little document while we're
Okay.
doing.
Okay, that works. All right. Andrew's bank account started off with a deposit of $750, and after 4 years, he earned $165 in interest. The simple interest Annual interest based on the deposit. Okay. So, do you have, do you know that formula? Interest for
Um,
simple interest, it's
I
principal.
know it, but I don't know it by heart. I believe it's
It's principal, which is the amount you started with. That's P.
yeah, principal.
The rate, which is, I believe, what we're trying to figure out, and T, which is time, which is years. So this is the I value, because that's how much he earned. It was $750 in principal. We don't know R, and we know that T is 4. So to solve for R, you can simplify the right hand side. You can multiply 4 and 750 together. That's 3000 R, and then just divide both sides by 3000. So you find that R equals 0.055, and you need to convert that to a percent. So you do that by multiplying by 100, and that makes it 5.5% annual
Like,
interest.
so with okay, because I know that there's different types of like there's simple interest, there's
Compound interest.
compound interest, loans. I think
Yeah.
that's what I kind of need. I'm trying to find like what
I
the
mean, I can make some up if you'd like, but
if you can, it's not. I mean, it's not that big of a deal. That's kind of what I struggle with a little bit too.
sure. So let's just do a home loan. Well, no, that's too big of numbers. So let's say your friend wants you're going to loan a friend $200 for the holidays, and you say, you know what, I'm not a credit card, but I'm going to charge you. Um, Credit cards charge like 18% interest or more. You're like, I'm only going to charge you 12% interest, and I'm only going to do it monthly. And your friend says, great, I've got to get through the holidays, and I know I'm going to get a tax return in April. So let's do 5 months from, let's call that 5 months. Is that okay?
Yeah.
Okay, so compound interest is P1 plus R over N to the N times T power. Have you seen that before?
Yeah, I have for
Okay.
yeah.
So you want to know, like, how much am I going to get back? Because you are going to loan your friend $200 and you trust your friend to pay you back. So P is 200. The interest rate is 12%. So we're going to call that 0.12. You always convert percentages into decimals. N is the number of compounding periods. So when it's monthly, that means that N equals 12. Is that okay?
Yes.
So that means this is 12. Now, T is always in years. So what's complicated is we're only doing this for 5 months. So that's really 5 over 12. Sorry, 5 over 12 for the number of years. So this can be fairly complicated to put into a calculator. It doesn't sound like you've got a great one there at your disposal. So I'll simplify this a little bit for you. Um, 0.12 divided by 12 is 0.01. So 1 plus that is 1.01. 12 times 5 over 12 is just to the power of 5. So let's go ahead and calculate that. 200 times 1.01 to the power of 5.
Oh, okay. 210.20.
So let me know if you get that value or don't get it.
Yeah, I got 210.20.
Great. So just thinking about this scenario I've posed, let's assume you had the $200 and you trusted your friend. Is it worth it to you to loan your friend to get that amount back? Are you surprised by that?
Um, no. Well, I wouldn't think it's worth it, but
Okay, I agree. So let's look at so a lot of times interest, and I'm a little bit on a soapbox here, but a lot of times interest is looked at negatively because it's usually talked about in terms of debt, car payments, mortgages, kind of all these financial products that are working against you. But
yeah.
um, you actually can use interest in a very positive way. Okay. The most recent time I looked at this, the average car payment in America, do you have any idea what that is, what that amount is? The average car payment is?
I would say like monthly, like
Yes.
400, 300.
It's actually like 505. It might have even gone up. But we're just going to call it an even 500 bucks.
Crazy.
So this doesn't work perfectly, but um, let's just say you you were gifted $5,000 from a family member. Let me undo that. Um, let's say you were gifted $5,000 from a family member, and they said, "Hey, you can go buy a car," and you knew, okay, well, I could get a car payment, or I could just pay cash, or you could save this money. So historically, the stock market has returned about 12% per year. It's actually like 11.7. Some people argue with that, but let's just use 11.7% per year for this problem. Um, you're fairly young. I'm fairly young. Let's say you could invest this money for 40 years at 11.7%, and it compounds monthly. Okay, how much money would you have at the end of 40 years? So to do this, it's the P1 plus R over N to the N times T power. You're starting out with that $5,000 gift from your wealthy aunt or uncle. Your interest rate, will use this 11.7%. So we're going to convert that to 0.117. We're going to divide it by 12, and it's going to be 12 times 40. So just to guess, like, well, how much do you think that $5,000 is going to be worth in 40 years?
Oh, and
Just a rough idea. Just what do you
I would
think?
say like 5,000, or no, like 6,000.
Okay, you're way off, but that's good. 0.117 divided by 12. I know this would be a little bit tough for you to put into your calculator, but that $5,000 would be worth $526,000. It's 526,773 and some change here. Kind of shocking, isn't it?
Yeah.
So why did it? Maybe you could see, like, well, why did he bring up that $500 car payment, um, which is what Americans generally have in their car payments. Um, it's just by a factor of 10. So that $500 car payment, just 1 month's car payment, if you could invest that for 40 years of your life, it ends up being $52,677.33. 32 cents. Well, how long do most Americans have a car
Uh,
payment for? Like how many years?
20. I would say 10 to 20.
So the typical is like 6 or 7 years. So without getting to like the real calculation of it, if you just said, well, they're making this car payment for 6 years, that's 72 of these. If you multiply this number by 72, and this is not the correct calculations, actually, it actually is much more significant than this. It actually ends up being like around $3 million. So a little bit of a tangent there for you, but the point is car. If you could invest a car payment, you could be a multi-millionaire in 40 years.
Yeah.
So it's kind of an interesting thing when you think about how much you want that car or don't want it. All right, have you had a chance to send any other questions to me or?
Actually, I'm going to send you one right now. It's a annuity, so it's a savings annuity.
Okay. Yeah, I was about that. That's what I was getting to with the car payment. It's essentially an annuity calculation, and it's really shocking how much um, you can have if you just start saving at an early age. But you gotta have work, you gotta have income, all that
Honestly,
stuff.
I've my first car. I only buy my cars off like Craigslist, but I guess I will someday have to have a car payment, unfortunately.
All right. Did you send that over to me?
Yes,
Hello. Oh, there it is. Great. All
I just
right.
put it under the first problem that I.
Got it. Got it. Okay. Suppose you decide to invest in an annuity that pays 5% compounded semi-annually. Okay. All right. I'm gonna have to look up the formula for this, but the 5% interest, that's your R. So your R is 0.05.
Great.
Semi-annually means that N equals 2. That's 2 times per year. Okay. T T is the number of years, that's 25. Okay. And the future value, they usually call this FV for future value, is 300,000 right there. And you're trying to figure out the payment, essentially what's called the payment or the PMT here. Um, if you don't have a formula handy, I'm going to look one up here.
It's not.
Yeah, I got it right here. So we'll copy that in. Okay, so you are trying to figure out the value of P, I believe. Is this what present value? No, value of each payment. Yeah, this should work. Um, so the thing that they don't tell you here is that R is really R divided by N, meaning like in your case, it's going to be 0.05 divided by 2 because you're doing it twice per year. The N here is really the T, but it's T times N because it's the number of payments essentially, which in your case is 2 times 25 or 50 payments. If any of this is confusing, it might be because this is the first time you've seen it, or this formula is very complicated and it's not usually very clear.
Yeah, I've gotten a lot of formulas this semester and this past. So yeah, most of them I believe I threw it away. No, I didn't throw it away.
Okay. Okay. So we're gonna run through this. So the PV, they're using PV, but it's really the future value depending on where you're looking at. That's $300,000. Your payment is what you're trying to find. That's P. Okay. So you now have in parentheses in the numerator you have 1 minus 1 plus. Now your R is really this 0.05 divided by 2 minus 50 to the minus 50 power all over 0.05 to the power of 2. So this right here is a number in the brackets. And you really need a scientific calculator to do it. Well, I mean, you don't have to, but it's very, very useful. I'm gonna do the calculation for you here.
So I'm gonna try, yeah. So 0.
Okay, so this part right here,
Is that to the negative 50 power?
it is, yeah. Just this part in parentheses though.
Is the answer down there the one that you got?
Yeah, this is what I got down here, 28.3623.
Oh, and then divide that. Oh, okay, sorry.
So now you divide the other side by that number there, and you'll get the payment, which it's not as much as you would think. Like you well, I shouldn't say it that way. Like their perception could be that it's a lot of money. I mean, it is, but it's not. Did I did I do 300,000? Huh. Actually, I don't know if this is right. This doesn't seem like the right value to me. Let me do it in another way.
Okay, I'm still trying to figure it out on my calculator.
Yeah, I guess that is right. That
Okay, yeah, I got that too.
yeah, I get the payment ends up being about $10,577 and 42 cents.
I just divided 300,000 by. I got 10,577.42.
Awesome. So that definitely takes us to the end of our lesson. Let me just make sure one thing before we close out here is the best number to reach you at 591-4770.
Yes, yeah, that is my
Okay,
that's my phone number.
cool. All right, I will send you out these notes and the screen recording here shortly. So
Thank
Thanks
you
again for.
so much, Matthew. You were awesome.
You're welcome. I'll see you next time.
Okay, thank you so
Okay.
much.
Bye now.
And then just